Hello students, in today's class we shall discuss about the matter and type of the matter and its properties of the how in the NEET examinations these classifications and different categories of the matters and their question shall be asked. So let us see about the first of all matter and its definition. So in this, matter can be anything that occupies some volume and has some mass. Anything present around is usually shall be called as a matter. For example, you take the book, pen, pencil, for example, this duster. All these are carrying some mass and also occupy some amount of the volume. So these all will be called as the matter. And apart from this, even water bottles, water and gases are also called as the matter. And you must remember that all living beings are matter. Why? Because they all have this some mass and occupy this some volume. So let us see the how definition has to be written. Anything that has mass and occupy volume is called matter. Then how many types of matter is present? Usually in standard forms, matter is present in the three categories. They are solids, liquids and gases. These are called the standard forms of the matter, and many other two forms also present, but we call only standard forms we take here. So let us take here solids. Second one, liquids. Third one, gases. So why matter exists in these three different forms? What is the main purpose that is keeping the various particles to exist in the form of the solids, liquids or gases? So that thing is called as nothing but intermolecular attractions. So when intermolecular attraction is the attractions among the particles or molecules is called as the intermolecular attractions. If intermolecular attractions are so strong, so these attractions will keep the particles together very close to each other so that they don't allow these particles to move around. If intermolecular attractions are weak, the particles are arranged a little bit away from each other. If intermolecular attractions are very weak, then the particles move away from each other and free movement of the particles is expected. Now let us see, in the case of the solids, the constituent particles are arranged very much close to each other. We all know that the particles in solids are arranged very much close to each other, leaving almost negligible space. And in case of the liquids, the particles are arranged little bit away from each other so that there is a free movement of the particles in case of the liquids. And in case of the gases, the particles are arranged very much away from each other. Almost very free movement of the particles is present in the case of the gases. So now let us see here how the solids, liquids and gases can be defined using certain type of the properties. So in case of the solids, first one is intermolecular attractions. Intermolecular attractions are very strong. Since intermolecular attractions are very strong, the free movement of the particles is completely restricted so that the particles cannot move from one place to the another place, and also these strong intermolecular force of attraction keep these particles together in a single place That is the reason why solids always have definite shape and also have the definite volume. So here we can write down that these are having definite shape and volume. And third one, no free movement of the particles. So why free movement of the particles is not there? That we discussed earlier, that because of the strong intermolecular attraction, the particles cannot move within the places or from one place to the another place. And when it comes to the next part of the liquids, so in the case of the liquids, we know that the particles are arranged a little bit away from each other. We can easily find that the gaps are present among these particles. So here intermolecular attractions are very weak. Since intermolecular attractions are weak, the particles are arranged a little bit away from each other. So here we can write down that these are having weak intermolecular attractions. Since intermolecular attractions are weak, these particles can easily move from one place to the another place. Since these particles are able to move, these liquids do not have any definite shape. But still the particles are present within this area. There is a free movement of the particles within the area, but the particles within the area can move from one place to the another place. So within the area only free movement of the particles is observed. So that since the particles are moving, liquids do not have definite shape. They have only definite volume. So here we can write down that have only definite volume but no definite shape. The shape of the liquids is nothing but the shape of the container in which they are present. And the third point here is free movement of particles is observed. Now, when it comes to the gases, we can easily see here that there is a lot of gap among these particles, so that it is clearly known that in case of the gases, the intermolecular attractions are very weak. Since intermolecular attractions are weak, intermolecular distances are too long. So since intermolecular distances are more, these particles can easily move from one place to the another place. So here we can write down that very weak intermolecular attractions are present. Second, very free movement of the particles is present. Since very free movement of the particles is present, these gases do not have definite shape. At the same time, they do not have the definite volume also. Why? Because if you take the 1 liter of the gas, we can keep this 1 liter of the gas in 1000 liters container, even a half liter container also. Why? Because here lot of gaps are there among these particles. So when you compress, they adjust themselves and occupy the little space. When you release the pressure, then automatically they try to expand to the container's volume. So that's why the volume of the gases is not definite. So these have no definite shape and volume. What about the free movement of the particles? So highly free movement of the particles is present. Particles is observed. Now let us try to see how to convert solids into liquids, liquids into gases, and gases into the liquids, liquids into the again solids. So if you observe how to convert the solids into liquids. One fundamental thing we need to observe here is the distance among these particles. Here, distance between the solid particles is negligible. Here, distance between the liquid particles is more. Means, whenever you want to convert a solid into the liquid state, you need to increase the distance between these particles. So, the distance between these particles can be increased by heating the process, by heating the solids. If you heat the solids, then what happens? Whenever you give the heat energy, these solid particles absorb that heat energy, their mean vibrations increase. You should observe, you should remember one thing, that here, these particles cannot move, only they can vibrate within the places after absorbing the energy. So when you are giving more and more amount of the energy, that vibrations increases, and finally at a particular point, they break the attraction forces and they go a little bit away from each other. That means solid slowly converting into the liquid. So whenever the gaps between the particles increase, then automatically it converts into the liquid state. So then how to convert the solids into liquids? By heat, by heating. Then I want to convert the liquids into the gases. Then again, how to do it? So liquids also can be converted to gases. Same process here also. Here intermolecular distances are comparatively gases is very less. Here very more. Means again we need to increase the more distance among these particles. That is done by giving the again heating. So when you heat again, so these liquids can be converted to the gases. And then the conversion of solids into liquids by heating, this process is called as melting. And liquids to gases by heating, this process is called as the boiling. Then how to convert the gases into the liquids? Again, same reverse process we have to do it here. Means you need to decrease these intermolecular attractions. Then how to decrease the intermolecular attractions? Here we can discuss one more important point, that we converted the solids into liquids by heating, liquids into gases by heating. Means every time you are increasing the temperature. That means the energy possessed by the gas molecules is more when compared to the liquids, and the energy possessed by the liquid molecules is more when compared to the solids. Since gas molecules are having more energy, they can move very freely from one area to the another area, having very little negligible intermolecular attractions. So when you want to convert the gases into the liquids, initially we have to do is we have to reduce their energy. So when you decrease the energy, then the first process happens is the kinetic energy or the movement of the particles gradually decrease. When movement of the particles decrease, then particles come close to each other. They give sufficient time for the molecules to develop the attraction forces. Otherwise, if these are having higher energy, they collide with each other and they go in a different direction. They don't give sufficient time for the molecules to develop the attraction forces. So that is the reason why we need to reduce these temperatures or energy. Then how to reduce the energy of the gas molecules? The energy of the gas molecules can be reduced just by doing the opposite process. That is, earlier we did heating, now we have to cool it. So when you cool it, gases will be converted to the liquids, because when you are removing the temperature or the energy, when you are removing the energy, automatically gas molecules get the sufficient time to develop the little attraction forces. Again, if you want to convert the liquids into the solids, you need to reduce the more amount of the temperature. So rapid cooling or high cooling is required here. So the process of conversion of the gases into liquids is called as the condensation. And the process of conversion of the liquids into the solids is called as the freezing. Then, what other property we can write down here? As I discussed, energy of the particles. Where energy of the particles is more, the energy of the gases, or else we can write down that kinetic energy of the gas particles is more than the kinetic energy of the liquid particles, which is more than the kinetic energy of the solid particles. So now let's try to discuss how many types of the matter is present and their classification. You can take the screenshot of all this. Now let us discuss. So now we should discuss the classification of the matter. Matter is basically classified into two categories. They are pure substance, and second one is mixture. This pure substance again being classified into two categories. One is element, second one is compound. And mixture is again being classified into two categories. That is homogeneous mixture. Second one is heterogeneous mixture. Now we shall discuss about all these things along with examples and definitions. So I'm erasing now. So first one is pure substance. So in case of the pure substance, all atoms are having same chemical nature with fixed proportions. So if a substance is having the elements with same chemical nature and fixed ratio of components. Actually, components we should not use. Composition. Fixed ratio of composition. So here usually question arises. What is the same chemical nature and what is the fixed ratio of the composition? So we shall discuss about this now. Example. You take the copper rod, sodium metal, third one, you can take the glucose, fourth one, gold. So by taking these, we shall discuss the what are the examples, means how to understand these examples and how these examples are satisfying these two parts of the definition. If you take the copper rod is having only copper atoms. All copper atoms are having the same chemical nature. There is no doubt. So this is a pure substance. Sodium metal having only sodium atoms. Again, they are having the same chemical nature. So again, it is called as a pure substance. Now, glucose, we know that glucose molecular formula C6H12O6. Then how glucose is having the same chemical nature? Because it is having the different type of the elements. But here, if you see the next part of the definition, it should have the fixed composition of the elements. C6H12O6. Whenever you call glucose, automatically it sparks in your mind that the molecular formula of the glucose is fixed. C6H12O6. As long as any particular compound or molecule is having the fixed composition, then it is always called the pure substance. So pure substance not necessarily to contain the atoms of only one element. It may contain the atoms of the different elements, but it must have the fixed composition. Next, let us take the gold. When it comes to the gold, usually one thing comes into our mind that gold is actually sold out in the market in two categories. That is pure gold, 24 carats gold. Second one is 22 carats gold. When you take the 24 carats gold, only gold atoms are present. Symbol AUR. When it is take the 22 carats gold, it contains gold plus copper. This composition is also fixed. So from one shop to the another shop, 22 carats gold composition do not vary. Once 22 carats means automatically gold and copper composition is fixed. As long as the fixed compositions are there, they are always called the pure substances. Now let us see two different types of the pure substance are present. They are elements and the compound. So let's discuss about the element. So what is an element? It contains atoms of identical atoms either in individual form or in combined form. So let us discuss about the element definition. Here also two parts of the definition is present for the element. Element always contains the identical atoms. These identical atoms may present either in the individual form or in the combined form. So let us take some examples that satisfies the definition and the how they are called as the element. Example: helium, neon, argon, krypton, xenon. If you consider all these, they are all individual atoms. If you take the helium gas, that helium gas contains only helium atoms. If you take the neon gas, that contains only neon atoms. If you take the argon gas, it contains only argon atoms. Like that krypton and xenon also. Means only one type of atoms are present, but all these are individual atoms. They are not in the combined form. They do not react with each other. There is no attraction among those particles because these are noble gases. Next, let us take the hydrogen, oxygen, fluorine, nitrogen, bromine, like this. If you consider all this, here also identical atoms are present. If you consider the hydrogen H2, two hydrogen atoms are present. Both are same. Oxygen, two oxygen atoms are present. Fluorine, two fluorine atoms are present. Nitrogen, two nitrogen atoms are present. Bromine, two bromine atoms are present. Means again, fluorine you can take any other examples also where identical atoms are present. So here identical atoms are present, but these identical atoms are not in the individual form. They are in the combined form because there is an attraction among the two hydrogen atoms here. There is an attraction among these between the two oxygen atoms. Here attraction between the fluorine. Here nitrogen atoms. Here bromine atoms. So basically element stands for it must have the identical atoms. That identical atom should present either in the individual form or in the combined form. Then the question is, what about the molecule? Whether the molecule is element or not. Now let us take here helium and hydrogen. Helium is an atom. We can call the helium an atom. At the same time, we can call this one as element also, but not the molecule. Because there is no attraction, there is no binding force between the two helium atoms in the helium. And H2, you can call this one as an element. You can call this one as a molecule. Why we can call this one as a molecule? Because there is a binding force between the two hydrogen atoms, hence it is called as a molecule, but not atom. Hope you understood about the element. Now let us discuss about the compound. So here, compound, it contains atoms of two or more elements, two or more different elements in a fixed ratio. You must remember that this fixed ratio word we are taking from the pure substance. So this element and the compound both are the part of the pure substance. That's why wherever you go, this fixed ratio word will come. So what is compound basically now? Compound contains atoms of two or more elements. What is the difference between the element and the compound? Element contains only identical atoms, whereas compound contains the more than one type of the atoms. For example, if you take CO2, here carbon and oxygen, both are present. So it is a compound. If you take H2O, is a compound. If you take N2O, is a compound. If you take some BrO3 minus, it is also compound ion. So now here, Cl2O7, it is also a compound. Then the question is, how to differentiate element and compound here? As I said earlier, H2, helium, CO2. Hydrogen we discussed already here, helium also we discussed. What about the CO2? CO2 is a molecule. Why it is called as molecule? Because attraction forces are present between the atoms. Wherever attraction forces are present between the atoms, they are all called as the molecules. So this is the molecule basically. And how many types of atoms are present? More than one type of atom are present. So that it is called as the compound. Can we call this one as an element? No, we cannot call this one as an element. Why we cannot call this one as an element? Because it is not having the identical atoms. It is having more than one type of the atom. So, but not element. So, this is about the element and the compound. Now, let us discuss about the, hope you take the screenshot. Now, let's discuss about the mixtures. What is the difference between the mixtures and the pure substances? In case of the mixtures, it contains two or more pure substances in any ratio. There is no fixed ratio here. It may be present in any ratio. Then, how many types of mixtures are present? Mixtures are of two categories. Homogeneous, second one is heterogeneous. Then how to define the homogeneous mixture and heterogeneous mixture? In case of homogeneous mixture, all individual components exist in a single physical phase. Homogeneous, they should exist only in the single physical phase. So let us take here one example. Dissolve sugar in water. When you put the sugar in water, sugar is present usually in the solid state. Water is present in the liquid state. After placing the sugar in the water, sugar slowly dissolves into the water and it also converts into the liquid form. That final form is called as the sugar solution. So here, initially solid state, liquid state, two different physical forms are there. But afterwards, they exist in the same single physical state. That is the liquid physical state. Now it is called the aqueous form. So they are all present in the single physical phase and uniform distribution of the particles is present. What is the uniform distribution of the particles? When you take the sugar solution, add the sugar, make it try to dissolve completely into the water. So make the sugar solution. You try to taste in this area or in this area, it gives the same taste after complete dissolution. That means uniform distribution of the particles are present. So wherever uniform distribution of the particles are present and having the single physical phase, such type of the mixtures are called the homogeneous mixtures. So what are the heterogeneous mixtures? Heterogeneous mixtures are definitely a little bit different from this homogeneous, and we need to understand it in an elaborate way. Let us see here, heterogeneous. So non-uniform distribution of the particles. Second, what about the physical phase? So a solution, heterogeneous mixture may exist in either single physical phase or more than one physical phase. Then how to understand these two definitions? Let us take non-distribution of the particles and we shall define these two also. Let us take some amount of the sugar and some amount of the salt. Place them in a beaker, don't add the water and mix them. Only sugar and salt are present. There is no guarantee that there is an equal distribution of the particles are present. Sugar particles and salt particles may not equally distributed. So non-uniform distribution of the particles are present. But here, both are existing in the same physical phase, solid physical phase. So heterogeneous mixture not necessary to be in more than one physical form. It is not necessary to be having the more than one physical state. It may have the single physical phase, it may have the more than one physical phase. Best example, just now we have taken both the mixture of this sugar and salt present in the solid form only. But here the condition is non-uniform distribution of the particles is present. Then what about the more than one single physical phases? If you take some amount of the sand and add it to the water. So when you add some sand to the water, we know that sand particles settles at the bottom of the beaker, so that even after 1 hour, after 3-4 days also you can observe that there is a sand particles in solid state and water in the liquid state. So this is a mixture which is not fixed because you are taking some amount of this and you are adding it. So it is a mixture, not fixed ratio. It's a mixture but exists in the two different physical states. So this is also called as the heterogeneous mixture. So condition for the heterogeneous mixture is only non-uniform distribution of the particles. It may exist in the single physical phase, it may be exist in the more than one physical phase. Now, another part, difference between the homogeneous and heterogeneous mixtures is heterogeneous mixtures can be separated by physical lead. Means you can do the filtration process. Here, salt and sugar particles by hand picking also we can separate that mixture. But in the case of the homogeneous mixture, since it is completely distributed throughout the volume of the solution, we cannot separate them by physical means. We need the other vaporization process or chemical means, then only we can separate them. So we cannot separate them by physical process. I hope all of you understand this class. Then let's meet in the next video. Thank you.